the sums. These I have discussed some of the important sums which these questions have come in the last 2 to 3 years in the board exams. The NCERT questions also have discussed. So these are the main three. So three types that we can solve equation in quadratic equation can be solved in three ways. The first one was the factorization method, the middle term factor. The second was the completing the square method. And the third one is the Sridharacharya formula, that is the quadratic equation rule. And the next what we learned was nature of the roots, that is whether it's real or it's not real, whether the roots are equal or it's not equal. So now let us look at the summary. So the summary is a polynomial of degree 2 is called a quadratic polynomial. You all know that. The general form of a quadratic polynomial is a square plus bx plus c. Note, it's saying polynomial. That's why this is not equal to 0. When this is equal to 0, it's basically an equation where a, b, c are real numbers such that a is not equal to 0 and x is a real variable. Okay, a should not be equal to 0. 1 is done. 2 says p of x is equal to a square plus bx plus c. This is a little printing mistake. This will be plus c is equal to 0. Ax square plus bx plus c is equal to 0, where a is not equal to 0 is a quadratic polynomial and alpha is a real number. Then p of alpha is a alpha square plus b alpha plus c is known as the value of the quadratic polynomial px. It's very simple. Basically, we have discussed that a quadratic equation has two roots, alpha and beta. These roots are real variable. These are real roots. So what they did is that they put x is equal to alpha here. They put x is equal to alpha here, and then they got this equation. Simple. Now number 3, a real number alpha is said to be a 0 of the quadratic polynomial this if p of alpha is 0, which means that ax square plus bx plus c is equal to 0. So suppose alpha, when we put the value of alpha over here, suppose alpha is 2. When we put the value of x as 2, if this equation, if the left hand side is 0, then alpha is said to be a real root. But if the equality holds, if x, the numeric value of x satisfies the equation, then it's a real root. If p of x is a quadratic polynomial, then p of x is equal to 0. That is ax square plus bx plus c is equal to 0. This is called a quadratic equation. We have discussed this. Number 5. A real number alpha is said to be root of the quadratic equation ax square plus bx plus c is equal to 0 if a alpha square plus b alpha plus c is equal to 0. That's what we just did. In other words, alpha is a root of this equation if and only if alpha is a 0 of the polynomial this. Okay. Now 6. If ax square plus bx plus c, where a is not equal to 0, is a factorizable into a product of two linear factors, then the roots of the quadratic equation ax square plus bx plus c can be found by equating factor to 0 number. It's very simple. You have learned polynomials in term 1. There is a polynomial. Suppose there is a cubic polynomial. Cubic polynomial can be divided. Cubic polynomial can be written as 3 products like this. 3. Suppose x plus a, x plus b, and x plus c. This is a cubic polynomial. When you equate this is as equal to 0. When you equate the cubic polynomial to be equal to 0, that is basically the process of factorization. Middle term factor, what we had learned. Now question number 7, point number 7, the roots of a quadratic equation can also be found by using the method of completing the square. We did that. Question number 8, the roots of the quadratic equation this can be found by using the quadratic formula. This is the quadratic formula. This is very important. You should memorize this formula. It's very easy to memorize, and the signs should not differ. The plus minus is outside the bracket, outside the square root, provided that b square minus 4ac is greater than or equal to 0, because it's real. Nature of roots of quadratic equation this depends upon the value of the discriminant, that is d is equal to b square minus 4ac, which is known as the discriminant of the quadratic equation. We did that. And number 10 says the quadratic equation ax plus b square is not equal to 0 has two distinct roots when d is greater than 0. Two distinct roots, for example, say 3 and minus 2. Two equal roots, that is coincident real roots, if d is equal to b square minus 4ac is equal to 0. That is, suppose say 3 by 2 and 3/2. No real roots if d is less than 0. Suppose 3i, 4i, where I is a complex number. Okay, so that is all that we need to do in quadratic equations. That's all we need to